Now let's talk about pH, is where we're really going with this. So when we're talking about pH, we need to talk about acids and bases. An acid is going to be anything that donates a hydrogen ion. So any molecule or compound that will give up a hydrogen. A base is going to be anything that will accept a hydrogen. So it wants to take it. When we put acids and bases into a beaker together, they will typically result in a salt. So, for instance, this is hydrochloric acid, HCl, and sodium hydroxide. We put these in a beaker together, and we will get water and salt, H2O and salt. So these will typically make a salt, because this wants to get rid of its hydrogen and this wants to take it. Right, so as we mentioned, acids and bases, from a chemistry standpoint, acids will give up hydrogens, bases will take it. From a pH standpoint, this works exactly the same way. Acids are proton donators, not protein, proton. They donate hydrogens, and bases are proton acceptors. They take hydrogens. Works exactly the same way. So pH is going to be a measure of the concentration of hydrogen ions in a solution. So when we take a pH sample, let's say you test the pH of your pool. What you're doing is you are testing what is the concentration of hydrogen ions in your pool. That is what that test is doing. So hydrochloric acid here, this is your stomach acid, by the way. This has a pH of 2. It is an extraordinarily strong acid. The reason why when you vomit, it burns your throat, and the reason why GERD is such a problem and why we want to keep it under control, is because it is a strong acid. Anything outside your stomach is not designed to handle this pH level. So it will literally destroy tissue. Sodium hydroxide, on the other hand, is an extraordinarily strong base. It has a pH of like 12, I want to say, off the top of my head. Honestly, you don't really need to memorize either one of them, but the stomach acid one sticks with you because, well, it's the stomach. It's something you actually use. Sodium hydroxide, on the other hand, we talk about it from a chemistry standpoint, but we don't tend to utilize it in physiology in the human body as a pH thing. So we'll talk about it here and there with chemical reactions, but we don't really talk about it as being its base, its pH number. All right, so as we mentioned, pH is based on the amount or concentration of hydrogen. Concentration is also going to be molarity, and it's a logarithmic scale, so it's in the order of tens. Changing one number on the pH scale is going to represent a 10-fold change in hydrogen concentration. So if I go from a 7 to an 8, I'm changing it by 10. Very important statement right here. As I mentioned this very briefly in the Unit 1 PowerPoint, our body will stabilize its pH. It will maintain it, provided your kidneys are working correctly, as much as it possibly can. And it will do it on its own without any aid from you. And the reason it's able to do that is your body has things called buffers. What are buffers? Buffers are substances that readily accept and give up hydrogen ions in order to help maintain the pH of whatever it's in. And that giving up and accepting will be based upon the hydrogen concentration. So as hydrogen concentration goes up, that means the fluid is becoming more acidic. These buffers will take up or bind hydrogen, trying to prevent the pH from becoming more acidic. If, however, it is becoming more basic, then they're going to give up hydrogen ions because the concentration will be getting lower. And in order to resist that fluid becoming too basic, these buffers will give up hydrogen ions, increasing the hydrogen concentration to help stabilize that pH. And your body is constantly doing this. All right, here's a pH scale. Neutral is 7. This is pure water. That's about the only thing we know of that has a pH of 7.0. Everything else is going to be slightly basic or slightly acidic. So we have things like cow's milk, saliva. Those are going to be like a 6.75, somewhere in there. Things like urine are actually closer to pH of 6. Coffee, pH of 5. Tomatoes, 4.75. Our sodas, citrus juices, vinegar, somewhere in about 3 to 3.5 range. They're all really close together. Here's our gastric juice, a hydrochloric acid. Coming up on the basic side here, if you're looking at this, bile. Bile is one of the most basic things in our body. Everything else is slightly acidic. Bile secreted by the liver, stored in the gallbladder, it's going to have a range of about 7.1 to like 8.9. And the reason bile is basic is because it will neutralize the gastric juice, but we'll get into that with the digestive system. Also bleach, about 9.5. Milk of magnesia you have heartburn. Yeah, that's going to be about 10 to an 11 pH. Ammonia, somewhere between 10.5 and 12. Lye, almost a 14. Super, super basic, super caustic.